Hello and welcome to Basic Tool Tech. This video shows how to do calculations on head loss due to pipe friction for laminar flow. Before we continue, it is important to define keywords like Reynolds number, laminar flow, turbulent flow, and friction factor. Let's start with Reynolds number. Reynolds number is a dimensionless quantity that is used to determine the type of flow pattern while flowing through a pipe. It is represented by the formula which you see right here on your screen, where rho is the where Re is the Reynolds number, rho is the density of the fluid, the V is the velocity of flow, D is the pipe diameter, and mu is the dynamic viscosity of the fluid, and this fancy V is the kinematic viscosity of the fluid. So you have to use the appropriate Reynolds number formula depending on the question. Let's look at laminar flow. Laminar flow is a case where the flow travels smoothly or in a regular path. Laminar flow are also called streamlined flow. This diagram shows you a laminar flow. As you can see on this diagram, the flow is smooth, it is orderly, and everything is just nice. This is a laminar flow. It is important to note that for a flow to be laminar, the Reynolds number must be less than 2000. So when a Reynolds number is below 2000, that flow is called a laminar flow. Let's look at turbulent flow. In turbulent flow, the fluid undergoes irregular fluctuations and mixing. Here is an example of a turbulent flow. As you can see, it is random, zigzag, and it's not orderly. For a flow to be turbulent, it means that its Reynolds number is greater than 4000. All right, so let's look at a friction factor. Friction factor relates to pressure drop and fluid effects. Now, why is friction factor important? For us to estimate losses in kinematic energy that the flow experiences due to head loss, it is important to calculate the friction factor. For a laminar flow, the friction factor depends only on the Reynolds number, and it is independent of the internal conditions of the pipe. Therefore, the friction factor for laminar flow is given by this equation, which is this fancy F is equal to 64 over the Reynolds number. Now, please note that this friction factor formula is for a circular pipe, and for this course we are dealing with circular pipe, so we have to use this formula for friction factor when finding the friction factor. Now guys, you must note that if the flow is turbulent, we can only find the friction factor using a chart. That chart is called the Moody Chart. I repeat that. If the flow is turbulent, the friction factor can be found using a chart, and that chart is called the Moody Chart. Now, back to this formula. From this formula, you can see that the friction factor is inversely proportional to the Reynolds number. Now, after we have computed or calculated the friction factor, the next thing we do is to find the head loss. And we can find the head loss using an equation which is called the Darcy-Weisbach equation. This equation is right here. With this equation, we can find the head loss for a flow. And The H subscript L is the head loss due to friction. The fancy F right here is the friction factor. The L is the pipe length in meters. The V is the velocity. The D, as you can see, is the pipe diameter. And G is the gravitational acceleration, which is a constant and is equal to 9.81 meters per second. So in our next part of this series, I'll be showing you the steps we use to find the head loss for a laminar flow, as well as I'll be showing us some examples in the next video. So please do not miss the part 2 of this video. Thanks for watching.